Okay, so hello everyone, and thank you for joining us today. My name is Jafar, and I work as a tech marketing manager for Red Hat. Today we have a very esteemed guest from the engineering, and we wanted to welcome you to this new session about. So usually we pick up different topics for the OpenShift coffee break, and this one will be a special episode because it's the first one of a recurring series that we wanted to do about pipelines. So we will specifically be speaking about Tekton, which is a Kubernetes native way of doing CI/CD. And today I have Siamak, Savita, and Nikhil from the engineering, and we have also our lifetime guest, Tero, who will still be sharing coffee with us. So if you guys can make a quick introduction yourselves. So who wants to go first?
I can start.
Okay.
I'm Siamak here. I'm a product manager for OpenShift Pipelines that based on the upstream Tekton project. And at Red Hat, I generally look after the CI/CD space on OpenShift.
Cool.
Yeah, I can go next. So here, thanks for having me here on the OpenShift coffee break. So myself, Savita, I'm basically part of DevTools group, and I basically work on OpenShift pipelines and upstream projects like Tekton, Knative. So currently, I'm based out of India, Bangalore office.
Okay, thank you very much for joining. And Nikhil,
Hello, I'm Nikhil Thomas. I'm also from Bangalore, India. I'm part of developer tools in Red Hat, and I contribute to Tekton CD projects, and I mainly focus on the operator and the productization part of OpenShift pipelines, where we bring the upstream components like pipelines to us into OpenShift.
okay, thank you very much again. And Tero, please.
Hi, my status changed from co-host to permanent guest since I worked for Red Hat last week, but currently working as a senior engineer DevOps in a company called Wangle. So I will be providing the external view of the things so that not everything is so, let's say, red and black and white. So I will be challenging Siamak and the engineering about pipelines and Tekton and upstream.
All right, you're very welcome to do so. And of course, Tero, we see that you are still wearing a red shirt. We know that even if you work for a different company, you can never leave Red Hat, right? So
correct.
Okay, so yeah, thanks again. So the goal here today is, as I mentioned, we're going to have a recurring series about Tekton, and of course, we will also speak about the productized version of it, which is OpenShift Pipelines. And the goal is to have pragmatic sessions where we go as we move along in the different episodes. We learn new things about the Tekton concepts, and we show you also how to do that. So it's not a master course, but it's basically showing you the different concepts, how to use them, how they work together. And because we have the great luck to have engineering guys from us, we can also understand better what Red Hat does in the communities, how we develop things, etc. So Siamak, since you are the product manager for that, how about you tell us a bit more how Red Hat got involved with Tekton, why we chose that, and what we do in the communities as a starter?
Sure. So I'll be happy to share, talk a little bit about that. So the continuous integration space is really is not in the shortage of solutions, right? There are, if you go like as long back as you go, 10 years, 15 years, there is a very colorful landscape, a variety of different solutions that target continuous integration in different ways. They all want to solve the same problem, that they want to automate the activities involved in software development lifecycle, like building the binary of your application, testing it, perhaps running some security checks against it. And there are more and more activities that all solve the same problem. You want to automate this, but there are different approaches to it. So this is quite colorful. And if you go a couple of years back, there is also a large number of cloud services that do the same thing. Look at Travis and Circle CI and GitOps Pipelines, and later GitHub Actions and so on. So it's really there was no shortage of solutions, if you will. However, as we saw, so Red Hat, like I'm a part of OpenShift. OpenShift is the Kubernetes distro, enterprise Kubernetes from Red Hat, and there is a sharp, really increasing adoption of Kubernetes across the industry. Not everywhere, but it really grows double digits, and a lot of organizations that are building cloud native applications, Kubernetes is not really it's a given that is a platform for deployment. So we see this growth of applications being deployed on Kubernetes, and the CI systems that are completely oblivion to the platform, to the container platform. So there was this gap that was discovered in the Kubernetes community, as the CI systems are very different from the infrastructure that the application is deployed on. And if you and when you're using cloud services, to an extent, maybe you don't even want that to be aware of your environment. But as you get closer to deployment, or if you want to run those in-house within your own infrastructure, even if your infrastructure is a cloud, but if you're the owner of the infrastructure, then it starts to become problematic, that way of that division that exists. Then you can also notice there has been a lot of efforts in bridging this gap, right? So there has been a lot of engineering efforts about how we can make Jenkins to work much nicer on a container platform, right? And you can see similar to other container platform, to other CI engines. You can see it also. So most of the cloud-based CIs, they do recognize the enterprise needs, and they have a version of that runs on Kubernetes, or at least the pipelines can execute in Kubernetes. And there are ways to have the runners, for example, to schedule the actual execution of the jobs in Kubernetes. So there have been a lot of efforts to sit in between and bridge these two worlds together, which works to a certain degree, but there are still limits to that. The obvious ones are, for example, one aspect is that how the CI engine itself, how well that is suited for Kubernetes environments. And the more traditional monolithic that solution is, the more difficult it is to run in a Kubernetes. Jenkins is a great example. Everyone is Jenkins user, Red Hat, including Red Hat. And running Jenkins on Kubernetes itself, it's difficult because Jenkins is designed really for a different era. It was designed way before containers were a thing. So the limits that exist is still that, for example, if when your application is deployed on Kubernetes, you keep your credentials as secrets on Kubernetes, and perhaps you have a secret manager that is managing those centrally across multiple clusters for you, or using a cloud key manager of sort. And then you have the CI engine that needs the exact same credentials, because it needs to go to the same Git repos or deploy to the same clusters. And you have a completely different way of redefining the exact same credentials. So now you suddenly have two different places to have the exact same credentials, and when you rotate them, update them, and so on. When you have configuration in one word, it's Kubernetes all config map, in other places it's different. So it's this different concepts like created frictions on how we bring these words together. So
Yeah,
this need was recognized first when the Knative project started by Google as a serverless platform at the heart of Kubernetes. And there it was recognized that we also need a build system that is more closer to Knative, closer to Kubernetes. All the CI system that can build container images are like really good, but all these gaps make it difficult to use it within Knative. So Knative build was formed to focus on this problem. And as use cases were like collected of what does Knative build need to do, quite quickly it was evident that we're not talking about building container images, we're talking about continuous integration. There are so many other activities around the build, not directly related to build, but need to happen right before or after building an image. So that was the pivoting point that the Tekton project that Knative build was broken out of Knative project and became really what Tekton is today. It became a project that focuses really on this gap between CI and Kubernetes, a CI framework that is really at the heart of Kubernetes, builds on the concept of Kubernetes. So you build your pipelines concept with the same concept that you're familiar with. You build a pipeline, you have tasks or stages of sort and so on, but you really build them with the concepts of Kubernetes as well. You have pods in it, you have containers, you have secrets, config maps. So for someone that is on Kubernetes, this seems a very natural step. The learning curve is extremely low because you are like reusing everything that you have from your existing skills and even constructs that you have on Kubernetes and build pipelines from them. So that was really the problem that Tekton tried to solve, to create a native CI that is built for Kubernetes, is familiar to Kubernetes, and inherits the operational model of Kubernetes as well. So it becomes really absorbed into the cloud Kubernetes platform.
all right.
So this is the background of the project, like not that brief background of the project.
Yeah, but that's the genesis. It's interesting to see how, like, I didn't know it came out of the Knative project. So, all right.
It's such a fast-moving project that it feels like ages ago, even though this is like 2 years ago or 1.5 years ago, if I'm not mistaken, like less than 1.5 years ago, perhaps. But it is. It's a very fast-moving project, and on OpenShift we do pride ourselves that we want to make Kubernetes simple for developers. Our goal is really to be the #1 developer platform for on Kubernetes. So we monitored this space very closely, and it was quite evident for us that Tekton is really the right direction for continuous integration on Kubernetes. So we started, we were already investing in Knative for serverless workloads, and we started investing in Tekton as well. We have two of the really sharp engineers on the Tekton team with me on the call, that we work a lot on upstream and address issues and bring customer cases that are very relevant within the enterprise environments, and work through them within the Tekton upstream project with creating enhancement, implementation, discussing, and then bring them down as a supported product to Red Hat customers.
All right.
I have an easy question to start. You mentioned that Siamak, there are several different like toolings to do the CI/CD. What about those customers? They have a zillion lines of Jenkins code, Groovy and scripting and everything. What is the way to move forward if they want to move to, let's say, Tekton? Is it lift and shift, or is it just the re-engineering, or is it the same concept like moving from VMs to container? Now is it moving from Jenkins to cloud native pipelines or something? Is there any like golden rules how that should be done?
I wouldn't say like this is the typical answer that you don't want to hear from me on this, that it all depends, right? It depends on what customer has done. But I would say that this is similar to any other type of change we have seen in the waves of technology, as technology matures and evolves, and you are left with the decision of how do I move from my existing way of working to this new way that addresses some of the challenges that I have. But at the same time, there's a lot of work for me, a lot of existing investment. So there's this trade-off of how do I address those challenges without like stopping still and spending a year just refactoring stuff, right? This was the same conversation when microservices and monolithic applications or thin container VMs, you mentioned, or this happens, like this is the exact same type of change. What we see at a lot of our customers is that they usually draw a line at some point, and any new effort that is being gone into CI or building pipelines or building a platform that provides CI as a service to internal teams, that redirects to investing in Tekton in this example, while maintaining and keeping the existing investment, and over time analyze and see where it makes sense to perhaps move some of those existing efforts to Tekton. But we don't see that often that people like stop and move everything that they have already on Jenkins or some other platform to Tekton. It's a more gradual movement, but absolutely, like this becomes a pivoting point that no new investments takes place, for example, in creating pipeline through Jenkins. That's the customers that started off in Tekton.
Okay, makes sense. I have actually another question to the engineering team. Since you follow the upstream closely, and the upstream is driven, of course, by the customers and the users, to which direction are actually the customers and user are demanding from the project?
So Tekton has become quite wide. So Tekton is it has the luxury of having quite a large number of vendors and individual contributors in the community, each of them bringing their own use case, the use cases of their companies or their customers to the community. So it really grows in a variety of different directions. But I thought I can get help from Savita and Nikhil that they focus on two of the sub projects of Tekton. They can talk a little bit about their areas of which direction they see in those areas that is growing. Would you like to go first, Nikhil, or ladies first? Actually, Savita.
Yeah. So yeah. Yeah, I think we both can mention some. So Savita, maybe you can go first, and then I can talk about other points as well.
Yep. So as Siamak mentioned, like most of the time I spend working on triggers, which is one of the sub project of entire Tekton CD, Tekton CD. So and also operators. So maybe Nikhil can address most of the things in operators. So coming to triggers. So initially, like when Tekton CD project started, it started with the pipeline project. I mean sub project module. So once they started pipeline thing, everything pipeline run and those things has to be run manually. So they got requirement or like use cases like how do we schedule these pipeline run or task run dynamically based on some events or some mechanism, so that those things will be dynamically run. In that case, a trigger event based mechanism they thought, and they started with this trigger project. So initially, they started with the alpha API. So that's how the Kubernetes API works. I mean, initially they start with alpha, then beta, then GA. So triggers is in the alpha state. So this first started adding the basic integration with the GitHub. So because most of us will be very familiar with the GitHub source code management tool, and this way they have started extending the SCM tools like GitHub, Bitbucket, GitLab. And after that, one flow of event mechanism started working. And later, like once the basic flow is started happening, then we got lot of requirements. I mean, user inputs like, okay, we want now customization of these event mechanisms. I mean, we don't want to use the just the basic inbuilt provided by triggers, and also we want something customization on top of that. So this way it started evolving, and now we have the customization step. And also, like, now trigger supports the knative based event listener also, because right now, till now, what was happening, whenever trigger creates the objects, the pod is keep on running even though someone is not sending events. So in that case, the resource utilization was unnecessary wasting. So in that during that time, like, we thought, okay, let's use the knative based mechanism also. So now the trigger integrates with knative also. Yeah, so this way we start adding the features based on the user inputs, or based on the use cases, and based on like lot of inputs from the developers, companies who started contributed. Yeah, so right now trigger is in alpha state, so maybe like another month or 2 months we will be making it to the beta. Then yeah, this is how we start contribute and add the new features to triggers. I think, yeah, Nikhil, can you just add some?
Just quick comment in
So
in the
just
between.
one
Jeff,
one
you can
second
go.
before, yeah. So just let's not forget that I know we are all very well versed into Tekton. We speak about those different concepts like event listener and triggers and stuff like that. But what I wanted to do, because let's keep in mind that this is a 101 session, we are basically introducing, although the audience might know, what I wanted to do is first have a quick recap of those main concepts, just to set the floor so everyone watching can understand what basically we are talking about. And then we can, if it's okay with you, we can articulate more in-depth information about those concepts. Would that work for you?
Yep.
All right.
Perfect.
So let me just, I'm going to share my screen and show you those different Tekton concepts. I will also
meanwhile, I will have a question.
Yeah, go ahead.
Maybe audience doesn't know that. Is it correct that when the API is in alpha, the API might change, but after beta, the API doesn't change anymore? And then, of course, GA it's solid. So that's good to know when customers start using Tekton, that if they use API, which is alpha, there might be changes and even breaking changes. So that's good to know.
Yep, exactly. So we kept triggers for around, I think, a year. I mean, more than 6 months is in the alpha state. So yeah.
Yeah, sure. Don't try to build productized CI or production CI based on alpha features. That's the goal or message there. All right. So very quickly, I'm going to introduce those concepts to set the floor. So as Siamak mentioned, what we wanted with Tekton, or what the community wanted, was to basically standardize around concepts that everyone will be free to implement how they want, but basically make those things able to work using Kubernetes native resources. So with Tekton, basically we extend Kubernetes with some new concepts. We use what we call the custom resource definition mechanism that allows us to enrich Kubernetes with new things. So basically, if we go at the very base layer, we add 3 things, which are the notion of a pipeline, the notion of a task, and the notion of a step. So a pipeline is a sequence of tasks that can run in sequence or in parallel. Each task will run in a pod, and each task will contain several steps that will run in containers in the same pod. So to give you examples, so all of those things, of course, are going to be defined the Kubernetes way, meaning using YAML resources. And if we see an example of a pipeline, we see here that we have several tasks that will for example, clone the source code, then build it, and then deploy it. So we can have conditional, we can have retries, we can have some execution logic built within the pipeline. But the very important thing that is, although all of those things happen in different pods or different containers, we can share data between all of those steps or tasks. So for instance, say that you wanted to clone your code, and this can be done by a task in a pod, but this pod will write the data to some shared workspace. We call that workspaces. And it's going to be, for example, a persistent volume that another pod can then mount. And if we wanted now to build the binary of the application using something like Maven, we find the source code already there. We can also use things like subpaths to say, I'm going to clone my code in this specific folder. I'm going to store my Maven artifacts or cache in this folder. So you can basically share data between the different pods that are playing some parts in your pipeline. Next steps are tasks. So each task is going to run in a pod, meaning that it's going to use a container image. So the great thing with that is there are existing tasks that you can find that we ship, for example, with OpenShift, or that you can find on a marketplace called the Tekton Hub. But if you were missing some specific binaries or scripts that you need to run your CI step, then it's very easy to build that into a container image. So that's one of the skills. So Tero, you asked, how should I move from my traditional CI to Tekton? So one of the, I would say, key skills would be to learn really how to write Docker files or create container images and embed whatever custom tools you need to perform your steps. So if you needed a specific CLI, then you have to build, if there's no image that already provides that, you can build your own image, embed all that tools within that image, and then you can reference it within your steps as your image that will run the commands, okay? And final concept is the step. And basically the step says, I'm going to use this specific image and I'm going to run this specific command. So for instance, if you wanted to build your Java application, then you could do a Maven package, or if you wanted to install your dependencies or whatever, you can do a Maven install, etc. So basically, you have a task that has several steps, and each step can have different commands with the container images. So that's the final concept that I spoke about, which is how to share data between different items. And basically, it's going to be a persistent volume that will be shared between different parts of your pipeline. So for instance, you will have a first task that will get some data, write it to the persistent volume, and then you will have another task that will reference the same persistent volume. We call it a workspace in Tekton concepts, and it will be able to find the data there. So these are the building blocks that you need to know about. And I have something that I have built also to talk about the triggers, but maybe let's save that for a bit later on when Savita and Nikhil show us the demo and try to expand the demo with this notion of, I'm going to make a commit to my code and then trigger the execution of my pipeline. All right, so that was it for the concepts. I hope it sets the floor to understand what we are manipulating in terms of resources and how they get executed on Kubernetes.
should we go now back to Nikhil to answer the question about the upstream?
You mean the direction in which the upstream is going? The question that we...
Correct. Yeah, let's finalize that question.
Sure, definitely. And thank you. So I can answer that question in two aspects. One is the general philosophy, and the second one is the direction in which the work is going. So the general philosophy is this. So that is, in the beginning, it was kind of assumed that Tekton is a tool that we use for the outer loop builds. That is, when you want to build and publish something in the enterprise. So at first, we did not have that focus of whether Tekton can be used for a developer's workflow. That is, I'm building a software and then I want to run some tests and and then just deploy in my local setup. But right now, discussions are going on in that aspect. That is, whether Tekton should consider this developer's local workflow as well. So one aspect is that we are also thinking about ways to make sure that CI/CD pipeline is also a part of the application instead of thinking about those two in two different terms. And the second aspect, that is the general work that is happening. So initially, a lot of focus was on the core functionalities. That is, how do we write a task and how do we share tasks and the different features that we need to share data between tasks or pipeline. Such things. But now the workflow, there's a lot more focus on supporting features as well. For example, as Siamak mentioned in Tekton, all the workloads run as containers. So when you run a pipeline, the tasks come up and they run as task runs, which is essentially pods. So all the logs, everything stays inside the pod. But if you want to retrieve those logs, you cannot keep those pods forever. So now there are projects like Tekton results in upstream. So basically, it's a method to upload or save your logs somewhere so that you can kill the task run pods. And then there is a lot more workflow-related work happening inside operator, because initially, the focus was on just installing the components. That is, you just want to install Tekton pipelines or just triggers. But now, people want to have access to methods using which they can automate upgrades, configuration, and customization. A good example is we have the operator project, which can be built for two different platforms. That is, when it is built for Kubernetes, it has certain set of behavior and it provides the upstream Tekton dashboard. But when we build the operator for downstream, it does not supply the upstream dashboard, but in addition, instead it provides some clustered tasks, which comes on OpenShift. So that in that aspect, there's a lot of focus now onto the supporting features or supporting workflows rather than on the core workflows.
Okay, makes total sense. But as I assume, it's a really fast-moving project.
Yeah, and speaking of that, so thank you very much, Nikhil. There's a question about pipeline resources, and because you guys have been involved in the upstream, like engineering discussions on all those things, could you tell us why they have been deprecated? I know there are some issues with them, some limitations. They have been mostly replaced by this notion of workspaces, where you can, instead of referencing pipeline resources, you can say the code is in this workspace and just use that, for example. Can you tell us more why they've been deprecated and what's the new way of doing that?
So I can give an overview. So that is, initially it was thought that the way we share workflows will be using pipeline resources. That is, we have types of pipeline resources like Git, image, storage, cluster, etc. And then there was a point where people were starting to request more and more types of pipeline resources. So, and the types of pipeline resources are inbuilt in the core Tekton implementation. So that is, each time we want to add a new pipeline resource, we'll have to add that to the core implementation. So that instead of adding pipeline resources, we thought about duck-typed pipeline resources. That is, so that is we can provide an interface using which users or other developers can create custom pipeline resources without having to make changes in the core implementation. But that did not take off. But instead, I think when Tekton started becoming popular, people were more interested in sharing workflows using tasks and pipelines. So pipeline resource, it's generally saying that, okay, so basically in simple words, pipeline resource is just a collection of steps. So if you use a pipeline resource, just before running your pipeline, it will add a few steps just before or after your defined steps. So for example, if you use a pipeline resource of type Git, it's just going to add the mechanism to clone the Git repository.
Yeah.
But right now, it is more clear for people to see that in a task, like the Git clone task. So the pipeline that you define is what you see running. But with pipeline resource, you see these additional steps running. It might be a little unclear. So, so two reasons. One, that is, it was kind of difficult to support more types of pipeline resources. And second, I think using tasks and sharing workflows using tasks and pipelines instead of pipeline resources makes it clear, more clear.
Okay. All right. Thanks. Yeah. So it's so the less concepts we have to manipulate, the easier it's going to adopt, to be able to adopt Tekton and those things. So thanks a lot. So I do have one question though. So I know you guys are working on the operator and extending it to make it easier to do things by instantiating Kubernetes concepts. So one of the things that I think are useful when you are doing CI or CD, for instance, is the ability to say, I'm going to pause execution for some time. And then when I get someone to approve this execution, then it's going to trigger a new pipeline or something like that. So are there plans to have this type of like generic approval concept added to Kubernetes as a CRD or something like that? Or can you tell us a bit more about how we are going to implement this notion of an approval gate using Tekton pipelines, for instance? If it's something that is in the works, if not, we can speak about the other topics. So
it's an open source project. You can implement it yourself.
Yeah.
I can speak to that. See if Nikhil and Savita want to add anything. I can speak a little bit about that particular topic. All right. Okay. So this is a very common request, right? And it really comes from, like I said, a majority of
traditional mindset.
Yeah, like not even traditional. A majority of teams have at some point been using Jenkins, right? And Jenkins, this is one of the like patterns you use. You add a manual approval there, and the pipeline waits for like things happen to outside the system. So, and I'm not saying this is only in Jenkins, but this like immediately comes to mind from Jenkins. So it's definitely a very common request, and there are discussions and requests on it within Tekton as well. There in Tekton, so some of the issues when you look at a Tekton project in the community are created as like this type of larger topic questions. What should we do about manual approval? So there is definitely a use case for that and interest within the community. There is also interest in it from like a lot of customers I talk to, because like I said, they're coming from some other CI system that force this. So at some point this will appear, I believe, in Tekton as well. The timeline is not known because the discussions, the community need to consolidate and come to a level that fits the Tekton model really well. The original thought was that these are really modeled at different pipelines. So at any point, if you have to really wait for a long time and then do something else, are they really a single pipeline? Or like there are two different sets of activities that need to happen, but you're modeling it as a single pipeline and connecting them with the manual approval thing in between. So that was like the original thought. But we do also recognize the case for even though they're separate pipelines, but having them together with manual step makes it easier to correlate these activities to each other. So much easier to have insight over the end-to-end flow and
exactly
those things that happen and the phases that happens on the system, but rather outside the system. So I would
for auditability and
yeah, exactly. So I do expect that this will appear in Tekton at some point, but we don't know yet when.
Okay, thanks. All right, so thank you very much, guys. So I believe, Nikhil, you had something to showcase what we talked about. Would you like to go over a quick demo of pipelines now running on top of OpenShift? Because I believe we add things on top of the core Tekton to have a very nice and productized version within OpenShift. Would you like to show that? Oh. So for info, we have 20 minutes left.
So we have prepared a brief demos just to give an overview of the different things that are possible with Tekton pipelines / OpenShift pipelines. So let's Savita will share her screen, and then we will take you through the demo.
Yep. Yeah, I'll quickly share my screen. Hope it's visible now.
Yeah, it is.
Yes.
Yeah.
I shall add one point here. That is, so just like Siamak said, the engine behind Tekton is Kubernetes. So there is no other, an CI/CD engine that we have to install.
Cool. Exactly.
So basically, so we can leverage our Kubernetes knowledge. So that is, we interact with Tekton the same way we interact with any other Kubernetes resource. So at the same time, one of our goals is to make sure that people get a feel that they are interacting with a CI/CD system, not Kubernetes. So that is where the dev console comes in. So what we try to provide is a CI/CD experience instead of having to deal with endless YAML files. Yes, you can always edit YAML files, but this is what we have. We want to show you how this Tekton CD, which leverages Kubernetes features, can be provided as an integrated system where you can forget that it is running on Kubernetes and use it as any other CI/CD system.
Yep.
All right. Thanks.
Yeah. So as we talked about operator and different Tekton CD components. So for the installation purpose, as Jafar said, we release our OpenShift pipeline as a productized stable build. So we recently released GA, which is 4.1. So yeah, I'm just going to the, this is a 4.8 cluster. So I'm installing the Red Hat OpenShift pipelines from the operator hub. You can see 1.4.1. This is the GA release we did last month. So I'll just, with few clicks, I could able to install the OpenShift pipeline operator on this cluster. So you can see lot of channels, but the stable is the one which we released recently. So yeah, I'll click on the install, and it started installing the operator with the OpenShift pipelines components like pipelines, triggers, and cluster task. All those things will be installed when we install through this operator. So you can see it's still under progress. It will take few minutes to install it. I hope it should come soon. and it always installing the OpenShift operators. So meanwhile, Nikhil, you wanted to add something about operators, like why we started adding the operators, why we are not using, instead of directly installing pipeline trigger separately, why we have to go through operator itself, what are the benefits we get?
In simple terms, we use operators to embed human operator logic into software. So which that means is that Tekton pipelines, triggers, all those are upstream projects, and which needs a lot more of human operator manipulation or a system admin's job to get them installed and make sure that they are configured properly and they upgrade properly without breaking your workloads. So that sounds like a lot of documentation and a lot of issues. So instead of that, what we are trying to do is gather all the best practices and recommended practices around around the life cycle of Tekton CD applications and combine them in software as OpenShift Pipelines operator. So then we are trying to take this operator to different levels of maturity. So that is initially it will provide installation and upgradation, and then we'll start supporting metrics. We can support backup and recovery, such things.
Yep. Thanks, Nikhil, for the brief information about the operator. So you can see like the operator is installed successfully. So in the installed this thing. And if we go like all of the Tekton pipelines, OpenShift pipelines components and pipelines and triggers will be installed in the project called OpenShift Pipelines. So now we are ready with the pipeline on our 4.8 cluster. So let's just install one of our basic pipeline to show like how a pipeline is created as part of our demo. So today we are going to show one of the front end and back end application integration and deploying through pipeline. And also we are planning to show like how we can send event from the GitHub so that a pipeline run will be created based on the events. So let's make use of this basic add flow through Git. No, so I will be installing one of the pipeline called front end, which is OTUI. So, yep. So I will be giving the Git URL as OTUI. So it should automatically choose the runtime builder, which is Python. So our UI application is in the Python language. So you can see here, we can choose any of this deployment or deployment config. So I'll go with the default configuration. And also here we get the like option whether we want to create a pipeline template or not. So I will be choosing this add pipeline, and then we have a create route application. So it means like for this UI pipeline, a route URL will be created so that we can easily access it. One more thing I wanted to show here in the visualization. So this pipeline, when it creates, it basically have these three tasks. Like first it will fetch the repository, then build it, and then finally it deploys it. So now let's create the pipeline. Yep. So it start creating the pipeline. We can see a good view of topology in the topology section of this pipeline.
So Savita, did you have any Kubernetes resources in your Git repo as well, or just the source code of the application?
It's YAMLs are there. So, but it doesn't take these YAMLs. It just take the code.
Right. It deployed your application and generated those manifests for you. And while you have them there, if you didn't have them, that would have been fine also. It deploys the application, generates deployment and route and service, and also added a pipeline for you based on Tekton that builds the application.
Yes, exactly. So you can, oh, sorry. I just created my pipeline in the OpenShift pipeline namespace itself. So we can see a lot of things here, but that's okay. So here you can see a pipeline OTUI application got created pipeline. But yeah, so we get error like image pull back up, because in the operator we have restriction, uh, some restriction to not to create any of the pipeline example or resources in the OpenShift pipeline namespace where actual components are running. So this is just a restriction we have added as part of our operator code. Nikhil, you want to add something like why we have added this restriction? Meanwhile, I'll create another namespace and create a pipeline over there.
Sure. Or Savita, as we are running short of time, you can switch to that 4.7 cluster if you have that accessible. Then you can show the final executed, pipeline run.
Yeah, sure.
If that's also possible. Okay, so okay, that's a good question. I mean, that's a good question about why that OpenShift Pipelines namespace is different from other namespaces. So, like I was mentioning before, the operator embeds a lot of operator knowledge. So that is one of the operator knowledge is when you want to run a pipeline or the Tekton application itself, it needs certain RBAC permissions and privileges so that it can run on OpenShift. So if you get the upstream release and then set it up, then all of this will have to be done manually. So what the operator does is it creates a service account called pipeline in all the namespaces with sufficient privileges so that it can be used to run your CI/CD workloads. But the operator doesn't create this pipeline service account in namespaces with a OpenShift or a cube prefix. So OpenShift Pipelines is a namespace where operator will not touch. So it doesn't have that default service account, which could build the image and then pull the image.
All right. Yeah. So now you can see the reason for not allowing to create the pipeline resources on OpenShift pipelines. So for the time being, I have created a new project called demo and I have created a pipeline over there. So this pipeline run is in the running state. So if you want to see like, okay, which step it is happening right now, so we can see fetch repository is completed. So it means the cloning of the code is done. Now it's doing the build. You can see the 4 steps over there: generate, build, push, and digest to result. So it's like create the Docker file, build it, and push it to the internal registry. And finally, we will get the SHA, so that the same SHA will be used in the deploy to deploy the things. So now, like meanwhile, if you wanted to see what all things it is going, we can go to log section and we can see, okay, so in which step it is exactly happening and where the progress is happening through these different steps. Now meanwhile, like until it happens, so I can show few more things here. So if we go back to pipelines and see here, like we have all these options. Like once we create through add flow, we will get a pipeline and a pipeline run running automatically. But later we do some edit to the pipeline and we wanted to run it again. So in that case, what we can do, we can click on start and it will we need to do this manual step to start the pipeline run again. So instead of that, what we can do, in order to avoid that manual interventions, we can add a trigger over here. So this trigger, basically what it will do, it will watch on the events and trigger a pipeline run for us. So maybe like maybe as Jaffa said, like we can stay tuned to the next episode for more information about the trigger and deep dive of the trigger concepts and how those dots will be connected from GitHub to the pipeline run creation. So for now, I'll just show the workflow here, not to the concept wise. So you can see here, like we have a list of providers supported, like we have Bitbucket, GitHub, GitLab. So for now, for the time being, I am selecting the GitHub pull request review comment so that I can send some review comment to the existing pull request. So for that, I am choosing the GitHub provider type and the repo is the OTUI, and you can see everything as it is the default values. So once I add this one, yeah. So meanwhile, you can see a pipeline run is success. So the pipeline run is success now. Now let's go to administrator view and see in the pipeline section, we have, as I have added triggers right now. So I can see a event listener and trigger template and cluster trigger binding. So like, yeah, the definitions and importance of these things we can see it later. So now what I'll do, I will get the URL for the event listener so that I can configure in my webhook. So yeah, this is the URL. I can go to networking section and the routes. I can get this URL. So if I directly hit this URL, I'll straight away get the error saying that, okay, I have not sent any body format, because GitHub pull request review comment is expecting some comments in the body section. So that's why if we directly hit the URL, we get this error. Now let's go to, this is the repo, which is my own forked one. So I can have a access to the settings. So what I'll do, I will go to webhook section and I will quickly add the webhook. So here I'll just remove the existing default values, and I have posted the webhook URL here. And trigger code expect the content type to be in the application JSON format. And by default, the push event will be selected, but I don't want the push event because I am interested in the pull request commit event. So I will be choosing that event here, and I will add a webhook. So this, once webhook is added, once it is success, you can see a webhook. You can see here no events are triggered till now. So what I'll do, for time being, what I did, I just created a one pull request, and it's kept it ready. So meanwhile, I'll just watch on the pipeline runs here. So if I go to pipeline section and pipeline runs, you can see there is only one pipeline run is running. So now what I will do, I'll just add some comment over here. Let me go to file changed and let me add one of just a simple comment. Yep. So once after I add this comment, a event will be sent to the event listener. Then event listener will do the operation of, yeah, I think it's taking time. Okay, so is GitHub page is working?
Maybe try to refresh the page.
Yeah, sure. So I'll just quickly refresh it. Yep. So let me go back to file changed, comments, add single comment. Oh, okay. So I think there is some issue with that. Yeah.
Try to reply under the first conversation that you started.
Okay, let me try
like,
that way. Or yeah. Oh, so GitHub is playing with us today. So all right. So let me try to delete something event. Okay. Wow. Nothing is working with the comment. Okay. So yeah, for time being, what so once we add this single comment, what it will do, it will just come here and start trigger the pipeline run. But I just wanted to show that.
it's fine. It's fine. We know it's not on our side that it's not getting triggered. So no worries. I can testify that it works. So thank you very much, Savita and everyone, because we are getting close to the end of the show. What we will do is actually for the next show, we will talk about the cinematic that happens to have that event trigger the pipeline with everything you said, like the event listener, the trigger templates, the trigger bindings, and everything, and explain how all of that works together. So that's going to be a second topic. And as we go along with those sessions, we are going to extend that pipeline with more complex topics. So thank you very much for everyone for your time. Thanks, Siamak, Savita, Nikhil, Tero. It was great to finally be able to start that show about Tekton pipelines and OpenShift pipelines. And I hope to see you soon in the next sessions. So,
Pleasure.
All right, I'm going to stop the stream, and thank you everyone who has attended. Bye-bye.
Have a nice day, everyone.
Thanks. Have a nice day. Bye.